start. Well, hello and welcome to everyone joining today. My name is Bill Klages, and I'm very excited to be co-hosting today's expert forum together with Mr. Sri Ravapati from Cation Labs. Hi, Sri. Sri will be facilitating today's panel roundtable. All attendees have been muted, and today's session is being recorded. So let's jump right in. Estimates put the number of deployed IoT devices in the market today at between 25 to 30 billion. When you think about it, each of us are likely exposed, willingly or otherwise, to dozens of Internet of Things devices on a daily basis. As consumers of IoT things, we exhibit different behaviors and habits in terms of how we acquire our stuff and how long we own and use these devices. The utility and use cases for devices seems to be infinite, from tracking sharks to trucks to our own children, to reading temperature and air quality and movements in commercial buildings, and a current proliferation of machine-to-machine, autonomous vehicles, robots, and drones with more complex AI software. We've all heard the unnerving stories about hacked coffee makers, home security cameras, speakers, and we know that anything that is connected is vulnerable. And what happens to all these billions of stuff when they become outdated and no longer supported by manufacturers? What are the risks, liabilities, and reputational concerns that linger when companies retire or discontinue devices that will likely continue in use? The leaps in IoT technologies, the speed of new devices to market, it's causing unintended consequences. Cost and speed to market result in manufacturers making security a low priority. And how will 5G and AI, substantial IoT platform enablers, further fuel the complexity of these challenges? Way back in 2015, CIO magazine contributor Nicholas Evans warned that when it comes to IoT security, it's the Wild West out there. We hope that today's session will provide you with an interesting discussion around these issues and challenges. And we encourage you to submit your questions via the Q&A feature, and we'll try to hit a few of those questions before we end the session today. We have the leadership from 4 great technology and security companies represented. Let me welcome our starting lineup. First, from Austin, Texas, we're very grateful to have Michael Cation, Chairman and CEO of SmarteBuilding. Michael is on the forefront of bringing new smart technologies to energy management and commercial control systems. A special thanks to Michael's team at SmarteBuilding for sponsoring today's event. Next, from Dallas, Texas, we're delighted to have Brian Bernknopf, Managing Director at QA Consultants. Brian is a leading software quality expert and heads the US business for the top dedicated software testing firm in North America. Brian is a frequent speaker at global CIO and QA events. And coming to us from the Bay Area in California, we're very pleased to have Gordon Hurst, CEO and founder of Cation Labs, an accredited testing lab and leading global connected device certification provider. Gordon and his team are pioneering cloud-based approaches to provide end-to-end regulatory compliance solutions to device manufacturers. Finally, joining us from sunny Waterloo, Ontario is Steve McGowan, Managing Director of boutique security consulting firm 360 Secure. Steve has a very rare skill combo that includes building and marketing telecommunications and innovative technology products to achieving recognition as a leading technology security expert. Now let me hand it over to Michael for a few words about SmarteBuilding and to kick us off with his opening thoughts. Michael?
Well, Michael, you're muted. You may want to unmute yourself.
Okay, there we go. Can you hear me now?
Yes.
SmarteBuilding develops and deploys IoT energy management solutions for the commercial building market. And I want to take the lessons learned that we've acquired over the last decade of deploying these types of solutions in the commercial building space, because we believe that you're going to see similar deployment dynamics in some of the other markets for IoT as well. And if you look at what's happened over the last decade, in the early days, the solutions that we deployed were really all about sensor data. We were just trying to gather data, bring it back to the data center, bring it back to the cloud, and analyze it. But over time, as those deployments matured, we moved more and more into control. And so that's lesson number one. Control has to happen locally. Because what we discovered is that networks that look like they are reliable from a sensor gathering standpoint, because if you drop a packet here or there, it's kind of no big deal. When you're controlling something, it becomes a very big deal. And so in IoT deployments, lesson one is control needs to happen locally. And I think the comment that really drove that home for me is one day the co-founder of the company looked at me as we were diagnosing a problem in one of our customers' buildings. And he said, "Hey, Michael, you've got to remember, we can make fire," right? So when you're actually controlling things that can make fire and have a material impact on their physical surroundings, that system has to work and it has to be reliable even if the network goes down. So it makes you really rethink how you deploy your IoT solution so that every element that you've deployed is standalone and well behaved, even in the absence of connectivity. Lesson number two was long-lived devices. If you look at the commercial building market, the expectation is that anything you put into a commercial building will have a minimum lifespan of 10 years. And a lot of times you'll see products and systems that are deployed that will have lifespans of literally decades. And so what that means from an IoT standpoint is that you have to manage a bunch of different technologies that have been deployed over time. And those different technologies have wildly different capabilities and wildly different approaches to security. The early IoT products and solutions that are out there had essentially zero security in them. Whereas the current state-of-the-art ones have the security infrastructure that's very similar to what you would see in a data center. And so really thinking through deployment so that you can manage and work well across very, very different technology generations winds up being really important for successful deployments. And then the final lesson that we've learned over the last decade plus of doing this is it's all about operations, right? Because if you look at what's happened in our market, as we've moved more and more towards control, it means that we've been pushing functionality more and more to the edge of the network. And each one of those little IoT devices, it started off looking like just a very simple sensor that could echo home some data. Well, now they look like a little embedded server. And what that means is every building that we are currently deployed in, that building from an operations standpoint, it looks like a data center, right? You're managing data center scale in terms of embedded devices that are essentially little embedded servers. And so those are the three lessons from the market that we participate in. And we believe that you'll see those same three dynamics play out in other IoT markets as well as those markets mature. And with that, let me turn it over to the next speaker.
Thanks, Michael, and thank you everybody for joining. Thank you, Bill and Sri, for coordinating this event and bringing us all together. Again, Michael, thank you for sponsoring as well, and to SmarteBuilding. As we come off of 7 months of being very digital and virtual and certainly more homebound, we've just completed Prime Day, and now Black Friday is looming in the holiday shopping season. Connected devices are going to be on everyone's mind, and I know Michael is really addressing a lot of the commercial applications, and then we also have consumer applications as well. And as consumers, we're unfortunately used to devices and their connected apps not being as user-friendly or easy to work with, or as expected. How many of us are surprised when we get a new gadget or a product and it just works? I suppose I'd be out of a job if that happened more often. But at the end of the day, we've got thousands of QA engineers working and supporting and contributing to that success. But you still end up with connectivity issues, as Michael was saying, and you have large risks with these systems, consumer or commercial related. But it's always these consumer products that are getting the focus and our attention. Connected equipment for hospitals, for ventilators in particular, has been a significant concern over the summer. And I don't want to really go any further with a comment on politics, but voting machines and their connected nature on everyone's mind these days as well. So, we certainly see both aspects of the connected things that are part of software development. As a software engineer, it's easy for me to marginalize these devices. I know that as a consumer, I expect hardware to fail. As Michael said, we expect a long shelf life for some of the hardware that's put into even our homes, but certainly in commercial applications. I've seen hardware fail. It's disappointing, especially as a consumer. But more often than not, it's a software issue, whether it's a missed requirement or a defect. And the average consumer sees these problems as one and the same. Whether the hardware failed or the software, they see it as a single functioning product, right? The hardware must both function as designed and sometimes even not as designed when these devices are used for other purposes. But together they have to act as a complete product, certainly in the eye of the owner or the consumer. So owners expect their purchases to function and to scale and to be secure. I'm reminded, I hate to go back to politics, but I'm reminded there was the app that was used during the primaries this year, and again, it's a hardware interface with your mobile device. It's network issues that are in between, and the failures there were highlighted in a very public fashion. And regardless of what that root cause was, the cascading effects of poor quality can have significant downstream impacts. But in all, it's the product that's admonished, and who's to blame, and what part of that overall product, needs to be can be separated out, but not in the eye of the consumer. So it's always easy to Monday morning quarterback as a consumer, and business products become more and more a significant part of our lives. We're not only exposed to the frustrations of product failures, but also revenue impacts and brand reputation impacts. But there's other aspects of it that also concern me. The issues of liability, legal consequences, those will continue to increase. We've spent a lot of time within my business focusing on connected vehicles, autonomous robots, smart homes and cities. These will all have opportunities to significantly, hopefully, improve our lives, but they'll certainly impact one way or the other. And when there are failures, who will ultimately be held responsible? It's kind of a modern day trolley issue that's just not relegated only to AI. So I look forward to the discussion, and thanks for having me.
Thank you, Brian, and over to Gordon.
Thanks, Brian. Hi, and welcome, everybody. I'm Gordon, founder and CEO of Mycom Labs, a regulatory compliance test and certification laboratory. As Brian said, by 2025, there will be literally tens of billions of data spouting devices connected to the internet. And they're already changing how we live and work. We are seeing IoT devices being deployed in homes for applications such as smart home security, energy saving, lighting, HVAC, and entertainment. In medical applications, we are seeing wearable health monitors that capture vital signs, remote patient care, including biometric scanners and sleep monitors. And for automotive, devices such as proximity sensors and cameras, diagnostics, systems reducing human error and making driving more comfortable and safer. Manufacturing industry is also witnessing rapid change. Remote monitoring, predictive maintenance, autonomous production, to name but a few. There is an increasing adoption of cobots that sort objects in a warehouse and are now even being used to be used in kitchens for cooking. And amazingly, if that were not enough, we are now seeing the Internet of Plastic things. No batteries or electronics required. This technology uses RF backscatter to communicate. Backscatter implies reflections. So you now probably realize when billions of IoT devices are operating simultaneously, it poses immense regulatory and operational challenges for both manufacturers as well as IoT solution providers. The ubiquitous use of IoT devices implies that billions of devices will overcrowd a limited spectrum. It also implies that there is an increased danger of devices interfering with each other's operation and potentially devastating consequences. I'll give an example. We recently tested a weapons detection system designed to detect concealed weapons on individuals in public spaces. We had to test the system to ensure it would not interfere with an autonomous vehicle's cruise control system. One can only imagine what would happen if the autonomous vehicle lost control and veered into a crowd where the detection system had been deployed. So today, over the course of today, I want to cover the broad strokes of some of the challenges facing IoT manufacturers and solution providers. There's regulatory compliance challenges. There's IoT implementation using wireless modules. For those who are new to regulatory compliance, a wireless module is a device that is plugged into a motherboard or system host. Available modules address multiple technologies. These technologies can be cellular, Wi-Fi, Bluetooth frequency hopping, Bluetooth BLE, Zigbee, ultra-wideband, and LoRa. I will also talk about non-certified and pre-certified wireless module selection. Future proofing with software-defined radios. Again, for those who are new, a software-defined radio is the only wireless module that can be legally updated while installed in the field, thereby future-proofing installations for the duration of the deployment. And finally, I'll be covering host device and co-location testing. Also market surveillance, implying that after the product is on the market, a random sample is selected for retesting to ensure continued compliance. So there are many interesting topics that I look forward to discussing. At this point, I'll hand over to Steve for his introduction on cybersecurity.
Steve, you got to unmute yourself.
Thanks, Gord. To continue where others have left off, I have a diagram here that essentially maps out what IoT security kind of is. And I think that's an important aspect from a security standpoint, simply because in security, we tend to rate what the risk likelihood or the risk profile of an application is by its criticality versus its likelihood of being impacted. And one of the things that you're going to run into when you look at IoT security as some sort of iconic concept is you get a lot of mixed messages. It doesn't seem to make a lot of sense. We get lots of information about ransomware, and sure, ransomware is a major problem in all aspects of IT security, but are you really worried about a ransomware on your wearable or on your coffee maker? Not particularly. And we can't seem to escape the slide that says, well, we're getting 50 billion devices and it's all about scale. Well, if you have ever worked with AWS or Azure, you know these guys can scale devices like there's nobody's business, and they're some of the best in the business at security. So that isn't necessarily a problem. What was really a problem is understanding that all of these use cases are entirely different from their risk profile. It shouldn't surprise you that a coffee maker designed to take out costs for the consumer, if it's going to be made with inferior product quality, it's also going to have inferior security. If we go to Black Hat and we demonstrate that we've penetrated a coffee maker or some other lame consumer device, you don't even get street cred for that. Because yeah, it should be easy. And consequently, on the other side of the coin, if we're on the power grid, if we are able to ascertain that this can be subject to all sorts of different types of attacks, that's obviously a really, really big problem. And maybe we're not as concerned about taking costs out of the solution. So when I look at the left, there's a bunch of questions that you can simply ask, and you'll get a completely different answer based on which one of these little icons you select. If we lose the coffee maker, yeah, it's no big deal. If we lose sensors on the power grid and they have access or credentials associated with them, that's suddenly a really, really big deal. In most devices, we can take advanced crypto engines for granted. HTTPS is almost ubiquitous now in the internet, but that's not necessarily the case in a wearable device. We don't have that kind of computing power. We have different understandings of what the lifespans of all of these devices are. We don't take it for, we take it for granted that you can simply go to a computer and say, you're in this country, you should follow this set of regulations and this set of certifications. Well, now your device can go on a truck and can move across different jurisdictions and become incredibly transportable. And finally, in terms of reading, who reads these things? So naturally, we're going to have a desire and an ability to read a single device from many different types of systems. And so how is that all coordinated in terms of access and credentials? Obviously, that's a very different problem between the power grid and, say, healthcare. And naturally, the IoT perspective changes, the risk profile changes for all of these different types of solutions. The one universal thing being is that most of these solutions are really enabled, not necessarily by technology, but by cost and battery life. And those are the things that are going to drive more IoT security problems in the future to produce all sorts of problems we've never seen before.
Thank you so much, Steve, and some great opening thoughts. I'm going to turn it over to my partner, Shri. I just want to remind all of the attendees to please submit questions or comments via the Q&A feature, and we'll try to respond to those near the end of the session. Thank you. Over to you, Shri.
Yeah, thank you, Bill. Those are some great panel opening statements. So let me start by saying, you know, a smart city could mean a lot of different initiatives. So I want to use the example of Columbus, which is heading to be the first smart city in the United States. Their initiatives were broadly focused on healthcare, smart usage of electricity, transportation using autonomous vehicles, broadband connectivity, and education. So the companies that are providing the solutions clearly have to jump through some hoops. The very first thing they have to do is to ensure that they meet their products meet the government regulations. Then they have to ensure that the product is tested for software, that's the front end, the back end, and the middleware. And then once the products are released into the market, then security becomes paramount. So we've seen, and very recently we've seen a lot of ransomware attacks on telehealth devices. So my question to the panelists is that, drawing from your experience in your respective fields, what are some of the major challenges that manufacturers and solution providers are seeing to bring their products into the market? And also, what are some of those challenges after the devices are actually deployed? So I'm going to ask this question to Michael, and the other panelists, please feel free to join in whenever you see fit. So gentlemen, the floor is yours.
Right. So, I mean, one of the big things is long life cycles, right? As you look at the IoT market, in the early days, it was kind of science fair projects, but it's really matured to the point where IoT deployments are expected to be an integral part of the setting in which they're deployed. And so the issue doesn't come on day one. On day one, everything works great. All your hardware is shiny and new. You've got the latest software release. All the devices are running the same version of the software. Everything's great. Where life starts getting fun is in year 3, in year 5, in year 10. And so again, it all comes back to operations in terms of operations over a long time horizon to keep that system consistent, to have it adopt new technologies as they're introduced into the mix, and to keep it well behaved and evolving as security protocols and models change over that period of time.
Yeah, I'll jump in. I agree, Michael. You know, one of the things that you talk about longevity of the devices. We also worry about abandonment and the use of those devices. Who owns the device and its ability to be disabled remotely if it's no longer fit for use, even if those consumers or industrial companies are still using them, right? Who's got that liability or responsibility? That that could make for some interesting discussions going forward as the years come by. Also, sure, you asked a little bit about what the challenges are for these manufacturers coming into the market. Again, as I said earlier, I think that one of the things that we see both, again, as consumers as well as businesses, is that they have to see it as a complete product. As a consumer, how many times do I see a really great product or device where it's got pretty bad software? And certainly I'm always attuned to that, and whether that's a usability issues or functional issues. We are all now smarter and should start asking questions as to whether or not, before I go ahead and sign up for an account, is it secure? And what am I doing once I start entering and providing data? But at the end of the day, from a manufacturer's point of view, we'd certainly like to see more of a combined effort. That obviously software development is more agile. We're seeing more rapid releases. It's a lot harder to do that on hardware. Hence the fact that it has to be built for the future, as Gordon and Michael commented on.
If I could jump in, the challenges facing manufacturers and solution providers are many. And I want to start by sharing another interesting true story. Some of the audience may have read or heard about it, but it's worthwhile repeating, and it drives home a point. Recently, in a small village in Wales, which as most know is in the UK, I'd love to pronounce the name of the village, but sensibly I'll leave that to the Welsh. For 18 months, residents were mystified as to why their broadband internet connection crashed every morning at 7 a.m. Engineers were deployed to walk around the village with a spectrum analyzer, trying to find the source of any electrical noise, thereby helping to pinpoint the problem, but to no avail. Turns out that an older couple got up religiously at 7 a.m. every morning and switched on their TV, which would in turn knock out the broadband connection for the entire village. Now, when I first read this article, I thought it was amusing. However, I then turned my attention to the more serious potential effects. Imagine if this were a connection used by emergency responders and lives were at stake. Most countries, specifically in the US, should there be any accidents or associated deaths involved with the authorities, that the authorities would not hold the old couple responsible, but would turn their attention to the responsible party. The responsible party in this case is the one who placed the device on the market. So there are times when IoT solution providers could potentially face consequences for placing non-compliant product on the market. Some additional challenges we have witnessed clients facing are placing IoT products on the market is challenging even for the most experienced companies. The regulations and processes are complex and they change frequently. Choose your target markets carefully, as the cost of ownership increases exponentially with growing number of technologies and countries supported. Each country has its own certification requirements, and no two countries have the same. Regulatory compliance information can be difficult to find and expensive if paying third parties to track it. Now we have a couple of interesting pieces of information I'd like to share with the audience. In certain countries where products are sold through distributors, the certificates are issued in the name of the distributor and not the solution provider. Beware of having a fallout with the distributor. You may find your company is held to ransom. We have seen this happen several times, and it's an expensive lesson. Further question is customs. We also see manufacturers bypassing the formal certification process, not getting their products certified through proper channels. In such cases, when shipments hit customs, these guys will put shipments on hold. There are horror stories about deployment of shipments being held due to customs involvement. This may not just affect lost revenue, but a company's leadership position within a particular market. This can be an extremely stressful period, potentially taking months to fix.
Yeah, I
Steve,
think
you
I
wanna
would.
add? Yeah.
Sorry, guys. I think I would jump in there when I hear about a city. So lots and lots of use cases. If they ever went with some sort of iconic solution or universal solution, let me give you a couple of examples at either end of the spectrum where it could be a little bit horrifying. So we mentioned education as part of the Columbus initiative. Well, you know, we've got kids today trying to log on to their systems at school with the COVID situation. And, you know, I have a friend and she teaches, and she's like having to tell her class, you know, of a bunch of 10-year-olds, no, you have to type in the full name, you know, with the @ part and the school name, not just your name. And she does this like every day, every single day. Okay. So we're going to take a system like this where you're not going to tell me we're going to cheat a little and make it a little bit easier. We're not going to make those light bulbs a little bit easier to turn on. Because I'm telling you right now, if we put down a security-based system for the traffic lights, for the light bulbs, nobody's going to turn on the lights, right? You won't be able to. It'll be this disastrous thing where I can't turn on the lights. Just put a light switch back for the love of God. I can't make any of this stuff work. Now, meanwhile, if you're going to put that system on, a lot of people don't know this, but there are controllers for the traffic lights. If there's ever an emergency where somebody can manually control those traffic lights. I've had days when I really wish I could control those traffic lights. Be a lot of
Me too.
fun. I might actually make a few things on time. Brian knows this. Brian knows I never get to anything on time. And so I'm going to put those two things under the same infrastructure with the same strategies and the same technology stack. And this is going to work. It doesn't have a hope in hell, quite frankly. So it has to be thought of in terms of the use case, you know, and we're right back to the risk identification and formulating the right strategy for this class of devices versus that class of devices.
So let me ask you, all the panelists, so now that you have outlined some of the challenges, what do you think are some of the best practices that you would suggest to manufacturers and solution providers to address those challenges? So Brian, you want to take that first?
Yeah, I'll take it. I wanted to just, before I do, I wanted to comment on what Gordon had said. I mean, there's one thing that's really interesting to me as we look at how these devices come to market. And we talk a lot about, especially because that's Gordon's and MyCom's role in this, is certification and regulation. And if I'm required to meet certain regulatory and requirements and certifications, that's where I'm going to focus my time. And that's on the hardware and maybe the embedded software. And as Steve said, if my use case is, medical devices, well, I've probably got some other software requirements as well. But generally speaking, I don't have a regulatory requirement for the software that hardware is connected to. So I'm not spending as much time on whether or not that software works as designed or works in conjunction with all the possible things that could go wrong on the hardware side. And I certainly see that as one of the drivers as to when we look at a product overall not failing, but certainly regulation drives everything. And if it's the hardware that's regulated, if it's the hardware that requires that stamp or that certification that MyCom can give it, the software doesn't get as much attention. But so back to your question.
But we did see the 62304 auditing that you have to do for medical devices, right? So.
Yeah. Exactly. As I said, certain fields require it, right? And they require governance over the software design process, but not necessarily the software, right? And did the software design and development process adhere to a standard? And that's great, and that has to be regulated. But at the end of the day, you have a lot of aspects of software quality that can go in the eye of the beholder in that case as to when they're ready to ship. And there's a lot of reasons to ship, even if the quote unquote testing is not done yet. So what are some of the best practices? What are the challenges? It's obviously easy for me, like I said, to play second chair or Monday morning quarterback, but investments in quality and security as part of the software process are in significant need, right? And certainly as we look at it overall as a holistic product. Steve mentioned it. Everything we do is about risk. So I would certainly recommend having a risk plan and understanding the risks of failure, both intended and unintended consequences of the overall solution or the device itself. If you know from the beginning where you're allocating funds in terms of preventing risk, potentially preventing lawsuits or litigation or other issues and compliance requirements, if those investments, it's a lot easier to get, again, speaking very selfishly, and this is what we focus on from a QA consultant's perspective, but it's a lot easier to get some attention around software testing and quality assurance, performance, scalability, all of these things when it's tied to compliance or audit types of risk mitigation strategies. And follow the same software development principles that you follow for general software. They can apply to the software that's embedded in and connected to IoT devices. These devices have a much longer release cycle, and they're released much more infrequently than software can be released, but it doesn't mean that the software can't be developed iteratively along with those hardware cycles, allowing for the product and the software to come to market certainly a little bit more connected.
Okay. All right. Thank you. Michael, let me ask you. So, smart cities generally mean, I think the very first thing that they're doing in smart cities is to put smart energy meters. So from your experience, what do you think are some of the best practices that you would suggest? Like, yeah, go ahead.
Okay. So I guess two comments. One, I think probably the most important best practice is to not think about IoT products as a product, but think about them as a service. Right? Because what we've seen, at least in our market, is you're not deploying into a static deployment arena. I mean, if you deploy an IoT solution into a commercial building, that commercial building changes almost daily. I mean, there's retrofits going on all the time. There's equipment being changed all the time. Usage patterns are changing all the time. And I think many of the IoT markets are like that. So you have to go into it with the mindset of, I'm not just drop shipping a piece of hardware or drop shipping a piece of software. You're deploying a solution, and that solution will evolve over time. I mean, these things are long-lived. It's absolutely going to evolve over time. And so I think the most important thing is if you go into it with the expectation that it is a service that's always being modified and updated and enhanced and changed, that will keep you out of a lot of problem areas. I guess the other thing is specifically looking at energy management. One of the things that's really interesting about energy management is it gives you a data stream where you can infer a lot of things. So one of the really interesting use cases for energy management is looking at the telemetry data that you're getting from electrical meters and inferring what's going on in terms of diagnosing equipment problems and things like that. And it is surprising how much you can infer about what's going on in a deployment by looking at real-time data over time and seeing how it changes over time. So I guess, looking at your IoT deployment and saying, what's the next step that you can do with the data? What's the additional level of analysis? What's the additional level of value add that you can bring to your customers once you've done that first phase of deployment is, I think, a really important mindset to have as well.
Okay, thank you, Michael. So Gordon, I think I heard Michael talk about fallback mechanisms in case of failures of devices. What are your thoughts on that? What do you think are the best practices?
Well, from a regulatory compliance perspective, there are many best practices available. They're not always followed, and I'm never cease to be amazed by companies who come to us who repeat the same mistakes over and over again, costing a fortune. But I would say IoT solution providers should place a high priority in having their devices certified by accredited and knowledgeable test labs. We recently had a customer who had to repeat the entire test program because they obtained test results from a questionable source. This, of course, cost the company not only delayed deployment, but increased costs. You may need to stay on top of changing regulations. Unfortunately, some countries publish regulations in their native language, which makes the process just a little bit more complex. When introducing products into global markets, there is good news for solution providers. Use of third-party wireless modules. This will not only be lowest cost to market entry, but will significantly reduce time to market. Multiple different technologies are available on a single slice of silicon. There are 3 types of modules having their own attributes. There is a non-certified module or in-house design module. These are actually combined into one and the same. And if you're using this type of module, solution providers will be responsible for all compliance testing and certification programs. Experience or guidance will be required here for beginning solution providers. Now there's a situation where you have pre-certified modules. And as the name suggests, these modules will be certified for 1 or more countries. Not all countries accept pre-certified module documentation for certification. Should this occur, you need to go to the host level certification, as this will be necessary. Software-defined radio modules are devices where some of the physical layer functionality traditionally implemented in hardware is now software-defined. And as mentioned previously, these devices are a good choice for IoT deployments, as they can legally be updated while installed in the field, thus future-proofing company investment. Potential IoT installations can have 10, 20, 30-year duration, and it's guaranteed the regulatory environment will change during this period, which is why the SDR option can keep systems current. To complete the compliance process, testing at host level, which is different from the module, will always be required. Several different types of tests will be required. And where more than a single technology is involved and are transmitting simultaneously, then co-location testing will be a requirement. For countries not covered by module certification, module test code will be required to complete the certification process. That can be difficult to actually get the chipset manufacturers to provide, and you may have to buy that code. If IoT devices are compliant to FCC and EU standards, then generally it implies potential compliance with most global markets. However, changes to frequency bands, output power, and operational modes for certain markets will be required. And finally, as I mentioned earlier, global certification is expensive. So partner with a competent test and certification resource to help create the best possible strategy, which in turn will reduce the cost and increase company ROI. And remember, if you think the cost of compliance is expensive, you should try the non-compliance route.
Hey, Sri, I just wanted to jump in. One of the things that Gordon was talking about there, it's really interesting to get lost in the idea that this is one device that might have multiple modules like Gordon was talking about. Think of a vehicle. a connected vehicle or an autonomous vehicle, as we start to see some of these larger, these are systems of hundreds, if not dozens, if not hundreds of devices, sensors. Each one of those would go through the process that Gordon was talking about in terms of certification. A lot of them are being built by third party and brought together. When we look at enterprise systems, non-IoT, so just software, enterprise software, the risk areas and the areas that we see, constant trouble is always the integration of all these systems trying to work together. Everyone is great at their job individually. Everyone knows that their stuff works, but when they throw it all together in an enterprise environment, something falls apart. And obviously
sorry.
Oh, go ahead, Steve. Yeah.
Yeah, I said, let me give you an example of exactly that. So the Nissan Leaf, this happened about, I'm going to say 5 years ago, but I could be off by plus minus a year. The Nissan Leaf had an app. You could download this app and it could turn on the seat butt warmers in the car. And that's pretty much all it could do, that and a couple of our environmental controls. Warm up the car, great feature in Canada, loved it. Except one of the things that they didn't really consider is that when we write software, we don't write it for the Nissan Leaf. Nissan's writing it for the Nissan family of cars, and somebody else is writing it for not just Nissan, but a whole bunch of other cars too. And subsequently, just because you had the app that said, well, here's what I could do, I could turn on seat butt warmers, great. Well, that doesn't mean I can't use my Unix device and substitute that for the app and make HTTP calls to it. And sure enough, under the surface, the API allowed me to turn on the engine. And that was a completely unintended consequence because the software components were separate from the hardware components, right? And we had to economically develop a solution that would fit across all sorts of cars. So some product manager guy is going, wow, the app can only turn it on and off. And well, who's to say that we need to use the app to do that? We can figure out how to use the same authentication mechanisms that the app is using. We can do that from a keyboard. And then you can poke around at the API and say, oh, well, all of these aspects of the API are actually available to us. Just because the UI says we can't do it doesn't mean we can't do it. Right. So that's a great example of how we can go with unintended consequences just simply because everything is just so complex. And there's not any one person who knows how all of this stuff is actually coming together.
Sure.
Like it's the sum of the parts. The sum of the parts. You can have all certified devices inside a single vehicle or a robot or some other larger system. It doesn't mean that it's all certified as one single device, whether that be the software or the hardware that's running it.
Yes.
Yeah, we have companies coming in for test programs. This is more on a local level, never mind the Nissan level. We have companies coming in and the guy sits down, he sets up his products. 2 hours later, he comes and says, I can't get it up and running. What do you mean you can't get it up and running? He said, well, I'm responsible for the hardware. And the software guy told me that this device would take that software and I could run it. I said, did you never try it? No, I didn't have to. He told me it would work. The number of times we have seen and heard that, and that costs money for them to sit there trying to debug their device. It's incredible. So it goes on at a local level, never mind the Nissan level.
Yeah. I think we have a couple of questions, Q&A. Bill, would you like to take over?
Sure thing. Thanks, Sri. Some great thoughts from the team. Let me start with this question. This is for you, Steve. Almost every week we hear about new vulnerabilities or strikes against IoT platforms and devices. What are the most recent vulnerabilities that concern you the most?
I think there are two classes of vulnerabilities that IoT, and even after I've told everyone that we shouldn't overly generalize on IoT, but there's a couple of dimensions associated with IoT in certain situations that are completely and truly horrifying, simply because they change the attack vector into a layer 8 or involve the humans, essentially, which means you can't just simply certify them out, right? And one of those types of attack vectors was well exemplified by the, if everybody remembered, there was when all of DNS fell down, it was the Mirai bot attack. And essentially what that did was that said, well, we're not going to penetrate everybody's webcam, but we can certainly point at it and send packets to it. And if we send packets to it, it will send packets back. So if we spoof the source IP address, it will send packets back to whatever that sourced IP address is. Suddenly that turns into an attack mechanism where I can take 50 billion devices and point them at something and fire packets at something. And that's a really different way of thinking about IT security now, that now you can become liable for basically other people generating attacks out of your infrastructure. And they can be devastating. I mean, we took down Google in some cases in that particular attack. So, you know, you can imagine what that would be like launched against, you know, a provider of a utility provider, perhaps. The second thing that I think will emerge from a social engineering point of view, you know, outside of your standard ransomware type of attack vectors, is just this huge amount of information that is you can gather. So, you know, not that I've had any of these nefarious ideas, but other people have. So what if we do have access to a light bulb? Yeah, it's a light bulb, right? No big deal. What if I have access to all the light bulbs in a city, in all the residences and in all the commercial sites? Do you not think that with a little bit of AI, we can actually figure out when the lights turn on and off? We can figure out when the lights are being utilized in a certain pattern. This is essentially allows a nefarious actor to case residences and commercial buildings and figure out, you know, because nobody wants to go steal anything while people are around. And instead of sitting on the street corner casing somebody's house to find out their patterns of when they go in and out the door, but you know, I'd rather do it in the comfort of my home with coffee, because I really like coffee. And essentially, when we do that type of when we look at things from that type of perspective, we begin to see all sorts of different types of attack vectors that nobody's ever really thought before, where all of this information at somebody's fingertips can be used for really, really nefarious purposes in ways that we've never imagined before. And I believe that that is going to be the next story of, dare I say the term IoT as a generic device.
Great. Awesome, Steve. I think we have maybe time just for one more question. I'm going to push this one over to you, Brian. From a software perspective, a similar question: what concerns you the most as it relates to IoT implementations and the life cycle?
Yeah, everything concerns me. I mean, this is what we're focused on. You know, the areas of risk, and Steve touched on it. I mean, whether it's security or scale or nefarious actors or any of these other things, it's liability. Right? These are individual pieces of software, whether they're embedded or drivers or overall, complete management administration systems, whether those be stored locally, stored on a cloud, or stored on the device. Who ends up with liability in these events? And autonomous vehicles get a lot of publicity for that, and just connected vehicles in general. They don't have to be autonomous to, as Steve was saying, to have bad things happen, or potentially. So I certainly spend a lot of time thinking about that. Who owns the responsibility? What are the liable parties when bad things happen? Who is thinking besides me? Who's sitting around thinking about all the bad things that could happen? And then obviously that all translates into budgets. It translates into decision making during the software development lifecycle, and integration to the hardware products themselves. And how do you do all of that? And I think Gordon, you mentioned it at the beginning, but putting these, or actually, the coffee maker example is a good one. These devices aren't very expensive sometimes to create, and so just because you're creating a cheap physical device or a lower cost physical device, it doesn't mean it has to be cheap in quality. But you have to balance that because you still need to get it to market and make money. Go ahead.
Yeah, I was going to say because it's always good to have the security guy who's always the Dr. No for everything to respond back in this particular way. And that is, because I've also built products in my life, there's a greater risk to all of this. And that is, if we don't get the costs down, a lot of these solutions actually don't exist. Right? They simply don't happen. When we're talking about sensors, we're talking about removing nickels and dimes off the cost of these things. So having the right framework to actually achieve all this in a cost structure that doesn't change the existentially challenged nature of this stuff is really where the sweet spot lies.
Very, very well. Well, thank you, gentlemen. We've run up to our time limit. There were a few questions that we weren't able to get to. However, we will follow up with some answers to those. We'll also make the recording of today's event available to all the participants. Once again, I would like to thank Steve and Gordon and Brian and Michael. And special thanks again, Michael, to you and the SmarteBuilding team for sponsoring today's event. Hope everyone stays healthy and safe, and good luck over the next 2 weeks until the elections. It's going to be a fun time, and we hope to see you again on a future webinar. Thank you, everyone, for joining.
Bill, can I just come in and say that for those of the attendees that wish a deeper dive into the regulatory compliance for the IoT devices, send me an email up there, and I'll send you a white paper. White paper is available.
Absolutely. Thank you, Gordon. We'll make some follow-up contact information available. So once again, thanks to all the attendees for joining. Have a great day.
Thank you very much.
Thank you all.
Thank you.